Alright, so we're starting Unit 4. Unit 4 is logarithms. Hey guys, we have 8 units throughout the semester, which means after Unit 4 we're probably going to have a what?
Midterm.
A midterm. Whoa. Right, so we got a midterm exam coming up after this unit, once we're done with the test. We will have a few review days in there before that midterm exam, but that is coming up, so you need to be aware of that. Unit 4 is logarithms. This should be probably brand new to you guys. I highly doubt any of you have seen logarithms before. If you have, awesome, right? Step up for you. Otherwise, for us, it's brand new. So, logarithmic functions, first and foremost. Why do we need them? Well, 2 to what power equals 4? 2 to the second power, right? 2 squared. 2 to what power equals 8? 3. Good. 2 to what power equals 6? Do we know? No. It's a question mark. We don't know that. And this is why we need logarithms. Right? To be able to solve this, we're going to need logarithms. We're going to have to switch it into log form. Because technically how we undo those exponents with an inverse is called a logarithm. So an exponential inverse. The reason we need logarithms is it is an exponential inverse. So the exponential inverse, that first blank on your paper, the exponential inverse is logarithms. We're going to call them logs most of the time. We're going to write it as log. You have to write out logarithm. You don't need to know how to spell it. Right? There's no spelling test. But you do need to know that the exponential inverse is called a logarithm or a log. Like I said, that's the first blank right on your paper. So, exponential inverse is a log. How do we use it? Well, like I said, a logarithm is an exponent. On your paper you can see you have 2 different forms. There's log form and there's exponential form. Log form. Y equals log base b of x. Right? That's how we say that. Make sure you're understanding how you say that. Log base b of x. That's your log form. Then exponential form is x equals b to the y power. Right? Something with an exponent in it. Exponential form. We're going to go back and forth between the two. Today we're basically practicing how do you go back and forth between the two. You should be able to know how to do this by heart because you're not going to get these on a test. Alright? So you need to know how to go from log form to exponential, exponential to log. So if we start in exponential form, 2 to the third power equals 8. If I want to switch it to log form, the base of my exponent is going to be the base of my log. So the base is always the base, whether it's of an exponent or of a log. And 3 and 8 are going to switch sides of the equal sign. So it becomes log base 2 of 8, right? When my exponential equals what I'm taking the log of, and my exponent is going to be what it equals. Alright? So that's how I switch from exponential to log. And same thing going backwards. The base becomes the base. 8 and 3 switch sides. 3 becomes my exponent. 8 becomes what it's equal to. Right? That's our big focus for today, is being able to switch from log to exponential, exponential to log. Right? So let's practice some of it. First one we're going to do, exponential to log form. 2 to the 5th equals 32. So the base of my exponent becomes the base of my log. So I'm going to write log base 2. You guys notice? 2 as a base is lower than the word log. Alright, do not write log, don't write this. Don't write log 2. That's not the same thing. It is smaller and down below. Kind of like the opposite of an exponent. Instead of going up, we're going down. Log base 2. Remember 5 and 32 are switching sides. I'm taking the log of 32 and it's equal to 5. My exponent becomes what it's equal to. What my exponential is equal to is what I'm taking the log of. Alright? So if I look at the second one, 5 to the 0 power equals 1. I have log, what's my base going to be? 5, right? The base of my exponent is also the base of my log. So it's 5 of 1. 1 and 0 are switching sides. Of 1 equals 0. What my exponent was is what my log is going to equal. Okay? Does that kind of make sense so far? Alright, 10 to the first power equals 10. I get log base 10, right? Base of my exponents, base of my log, of 10 equals 1. Does that make sense? Are we all okay with that? Do we have any questions on it right now? We just need more practice. Speak now for everyone's peace. Alright. So let's do it the other way. Let's go from log form to exponential. Log base 10 of 0.1 equals negative 1. The base of my log becomes the base of my exponent. So 10, I remember 0.1 and negative 1 are switching sides. So what my log equals becomes my exponent. So 10 to the negative 1 equals 0.1. The second one, log base 5 of 125 equals 3. Base of my log becomes the base of my exponent. So 5. What my log equals 3 becomes my exponent, and it equals what I took the log of, so 125. Now guys, if you write on your paper and it asks you, hey, can you switch this to exponential form? You write 5 to the 125th power equals 3. Does that make any sense? No. Do you think we'd have you write something that doesn't make sense? No. So make sure it makes sense if you're just switching forms from log to exponential or exponential to log. Alright, then log base 1/2 of 2 equals negative 1. Base of my log, 1/2. Is the base of my exponent. 2 and negative 1 switching sides. What my log equals is my exponent. What I'm taking the log of is what it equals. Any questions on those? Yes, sir.
When you have a fraction, would you have to write it in quotation?
You don't have to. I always do just so that I know that the negative 1 is that whole fraction. It's not just like 1 to the negative first over 2. But if you have it spaced out enough where it's like 1/2 to the negative 1, I'm fine with that. Jay, what's up?
Would you write a decimal so the fraction?
You can write 0.5, yeah, as long as it's a nice decimal. Like if you have like 1/3, so it's like 0.33333. Like I don't want that. Like if it's a nice decimal, yeah, for sure. All right. Special log expressions. We have 2 of them. So the first one, it's when I take the log of 1, it always equals 0. It never matters what my base is. If I take the log of 1, wait, hold on. Let's talk about. We'll do a special log, and then we'll go back to common logarithms. All right. So if I take the log of 1, no matter what my base is, it will always equal 0. Because if I switch this to exponential form, I get b to the 0 power equals 1, and we know from our exponent unit that anything to the 0 power is always 1. So anytime I take the log of 1, no matter what my base is, it will always equal 0. Then, our second special case. If I take the log that is the same as my base, so log base b of b, log base 8 of 8, log base 12 of 12, if these are the same number, it will always equal 1. So once again, if you switch it to exponential form, whatever it is to the first power will always equal b. Right? 8 to the first power is always 8. 5 to the first power is always 5. 12 to the first power is always 12. So these are our 2 special cases. If you take the log of 1, it equals 0. If you take the log that is the same as your base, it's 1. Alright, right above it, it says common logarithm. The common logarithm. Logarithms with a base of 10. So like log base 10 of x. We call it the common logarithm. Why we do that is because we can also write it as log of x. It is the most commonly used logarithm. Alright? So if there's ever a number or ever a log that does not have a base, you can assume it is a base of 10. If you look on your calculator, there's a button right underneath x squared. It says log on it. Right? That is a log with a base of 10. It's not a base of 2, not a base of 12, not a base of 16. It is always a base of 10 because that's our common logarithm. It's one that's used the most. Now, we may not use it the most, like in the real world when people actually use logarithms, that's the one that's used the most. So our common logarithm is a base of 10, or there's nothing written there. Like I said, if there's nothing written there, you can assume that it's a 10 for a base. Okay? Cool? Okay. Evaluating logarithms. So we're going to do this without our calculators. Whoa. Crazy. And then we're going to show you how to use your calculators, alright? So first things first, best way to evaluate a log expression, change it into an exponential. Right? Anytime, we're going to learn this tomorrow when we do solving, you start with logs, you probably have to change to exponential. Start with exponential, probably have to change to logs. So how many of us know what log base 2 of 8 is off the top of our head? None of us, right? That's what we're saying. Change it to an exponential first. So if I do that, I'm just going to set this equal to some variable. I'm going to choose y. If you want to use x, use x. If you want to use m, whatever you want. And I'm going to change it to an exponential. Base of my log becomes the base of my exponent. What my log equals, 2 to the y power. And what I'm taking the log of is what it should equal. So if I change it to exponential form, 2 to what power equals 8? 2 to what power equals 8? 3. We can figure that out now, right? When we had the log, we had no clue. We don't know what log base 2 of 8 is in our heads. But we can probably figure out 2 to what power equals 8. Right? Pretty easy. The next one. Log base 10 of 10,000. Change it to an exponential first. Right, I'm going to let it equal y. We get 10 to the y power equals 10,000. Well, 10 to what power equals 10,000? What? Not 1,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So we should get 4. Y equals 4. Right, so change it to exponential first, then try and solve it. Alright, try the first 3 please. 1, 2, and 3. If you want to keep going past that, go ahead. But I just want you to try the first 3 for right now. Those first 3 you try, so what ones you have to do? If you have questions, raise your hand. Ask a question. Yep, so just figure out what would y equal in those cases. That's supposed to be 43rd.
That's not that.
And
There you go.
guess and check 8 to what power? Okay. So I guess one thing, you know, anything to what power equals 1? Anything, any number to what power equals 1? 1. Any number, there's a certain power. If you raise any number to a certain power, it's always going to be 1. Talked about this last unit. We'll keep trying these. Try those two at least. Okay, we'll come back to it. Yes, sir. How do we look at that? We haven't learned that yet. We got to change it to an exponent first. All right, should we go through the first 3? Yes. All right. First 3, log base 8 of 1. How do I rewrite that as an exponential? Cam?
8 to the x equals 1.
8 to the x equals 1. I'm going to use y just because I put up there, but yeah, you can use whatever variable you want. 8 to the x equals 1. So what does x or y have to equal?
0.
0. Right? We said anything to the 0 power equals 1. Doesn't matter if it's a positive, doesn't matter if it's a negative, doesn't matter if it's an inanimate object. Anything to the 0 power equals 1. Very good. Second one. Log base 4 of 64. How do I use an exponential, Isaiah?
4 to the y equals 64.
4 to the y equals 64. And what'd you get for y?
Y equals 3.
Y equals 3. Good. 4 to the third power is going to equal 64. Awesome. Log base 9 of 9. How do I write as an exponential? Bailey.
I said equals y and then 9y equals 9 and 1 equals 1.
Perfect. 9y equals 9. And we know y is equal 1 because 9 to the first power equals 9. Awesome. Did anyone try the fourth one and figure it out? You what? You failed? Jay, what'd you do?
5 to the y equals 1.5. Y equals -2.
Perfect. How'd you get -2? Did you just guess and check or did you think about
I
it?
guess a check.
You guess and check? That's perfectly great. That's fine, right? Now, if we think about it, he's right. Y has to equal -2. But why does it have to equal -2? Ryan, do you know?
Yeah, because 5 times 5 is 25, and then we're mixing them down.
Yeah, 5 times 5, so 5 squared is 25. And remember, when we have a negative exponent, guys, what do we do with that number?
Yeah.
We have to flip it, right? So anytime I go from a whole number base to a fraction answer, it's going to have to be a negative exponent. All right, so in this case it ends up being -2 because I'm going to flip it, flip 5 to 1 over 5, then I have to square it to get to 25.
So anytime you have a fraction, it's going to be a negative.
Anytime we go from a whole number
To a fraction.
to a fraction, it's going to be a negative exponent. I might even write that on my paper. Anytime we go from a whole number to to a fraction, it's going to be a negative exponent. Good. All right, I'm going to skip 5 for just a second. I want to do 6 first. Okay? So let's do 6 first. If I change it to an exponential, I get 9 to the y equals 3. Right? Thank you, sir. Do we all agree with that part?
Yeah.
Okay. What's y going to have to equal? What? 1/3? Oh, not 1/3, but you're in the right direction. You're going in the right direction. Jay? 0.5 or 1/2. Did you guess and check again? You did? Okay, that's fine. Let's think about it though. Why does it have to equal 1/2? What is 1/2 the same as? Do we remember? What's another way to get from 9 to 3? What did we do last unit? We had radicals, right? The square root of 9 is equal to 3, correct? The square root of 9 is the same as 9 to the 1/2 power. Whoa! Does that make sense? So guys, when we're going from a whole number that's a base to a smaller whole number, we have to take a radical, or our exponent is going to be a fraction. Alright, so we said going from a whole number to a fraction, our exponent was negative. Going from a whole number base to a smaller whole number answer, our exponent will be a fraction. Now the next one, we're going back to number 5, and I'm going to show you a really cool trick, an easy way to do it. If we go back to number 5, and I set up as an exponential, I do 32 to the y power equals 2. First and foremost, we should realize I'm getting smaller, so I know it's going to be a fraction. The easiest way to think about it, guys, is to think 2 to what power will get me 32? 2 to what power will get me 32? I thought I heard something say
5.
5, the fifth power. So I know the fifth root of 32 will give me 2 then. Right? I'm working backwards. 2 to the fifth is 32. The fifth root of 32 is 2. Well, the fifth root is the same as 32 to the 1/5. So what's my exponent have to be then? 1/5. So if you think about it as 2 to the 5th gives me 32, then 32 to the 1/5 has to give me 2. So work it backwards if you need to. Let's try it one more time. (125) to the y power equals 5. 5 to what power? Because I know it's going to have to be a fraction. 5 to what power gets me 125? 3. So that means 125 to the 1/3 will have to give me 5. So if you look at it the way we normally do, where we go 5 cubed equals 125, I know 1/3 is an exponent will get me to 5. It's the same as the cube root is 125. Alright? Does that make sense? So you should remember 2 things from this. If I'm going from a whole number to a fraction, my exponent must be what? Negative. If I'm going from a larger whole number to a smaller whole number, my exponent must be a fraction. Alright, those are the 2 big things. Does that make sense? Do we understand that? Do we have any questions? Okay, we have one more we're going to do. Log of 0.001. Yes, sir.
I know how to set it up.
You know how to set up? How do you set it up?
10 to the x equals 0.001.
Good, right? If you let it equal y or x. We have a base of 10. It's a common logarithm, right? We just talked about that. So 10 to the y equals... Now, I'm not going to use 0.001. I would rather use a fraction. What would that be as a fraction? Do we know? Isaiah?
No, I don't.
No, I thought you were raising your hand there for a second. Well, it's 1/1000th, so I would assume this fraction would be 1/1000. Alright, so I'm going from a whole number to a fraction, which means my exponent is going to have to be what? Negative. Good. So if it's negative, 10 to what power gets me 1000? The negative third power. Right? The negative makes it so I flip it into the denominator, and then the 3 gets me from 10 to 1000. Does that make sense? Do you have any questions on that? What questions do you have? Ask them right now. Do it. Nothing? Okay, we have one more thing we're going to do, and then we're going to look at our test. Cool? The next thing's super easy. We're going to talk about how we put in our calculator. So if you don't have a calculator out, please get it out. Alright. Like I said, guys, logarithms with a base of 10 are called common logarithms. That button, that log button on your calculator, is the common logarithm. So if you're given something like log of 7 or log of 1000, you can just use that button right there. You can click log 7, enter. Go ahead and do it. Log 7, enter. Log 7, enter. Do it. Wrong class. Hate when that happens. Alec, what'd you get?
0.845.
0.845. And it keeps going, right? Alright. Log 1000. Enter. Do it. Now. Please. Ev, what'd you get?
3.
3. Good. Guys, when you put yours in, did you get those 2 numbers?
Yeah.
Okay, good. Well, what if it's not a base of 10? We can't use that log button. What we can do, though, we're going to end up using the log button, we can use what we call the change of base formula. Right? It's changing into a base of 10. So change of base formula. I don't know if it's written on your paper or not. Is it? Oh, you gotta fill it in. Log base b of a equals log of a over log of b. So you log of, you're taking the log of over the log of your base. So in this case, log base 2 of 256, it'd be log 256 over log of 2. And this we can use that log button for and put in our calculator. But you need to be very careful. Make sure you close your parenthesis after 256. Right? So if you put in log 256, close the parenthesis, divided by log 2. Also, if you look at Evans, and it's log 256, you gotta make sure you close that parenthesis on there. Yep. What did we get when we put that in?
8.
8. What'd you get?
8.05.
Ooh, did you close your parenthesis?
Yeah.
You did? Let me see. What?
Oh, that's right.
Alright. What everybody else? You got 8? Everybody else get 8?
No.
No? You should have gotten 8. Let me look. Let me see.
He got 7.5.
Get divided by log 2. Alright, I'll give you a second. If I set up the second one, I get log 1, 6, 3, 8, 4 over the log of my base, which is log of 4. Try that. Isaiah, did you get it figured out? Yeah. Alright, so put the second one in your calculator, please. Hey guys, just an FYI, I do not believe we give this to you. You gotta know that, alright? I don't think we give that to you on a test. Alright, what did we get for the second one? 7? We all agree?
Yes.
Alright. Evan, hold the calculator for a second so everyone can see it. If you have a calculator like Evan's, you're gonna have to do it with change of base formula. The older calculators, you have to use change of base. If you have a calculator like Miss Baker here, one of the newer ones, you can hit the math button, and you can go all the way down to A. It's off the screen to start with. Go down to A, it should say log base. You click on that, you can put whatever base you want in, and whatever number you want in, you can put in log base 2 of 256 right away, and hit enter, it should give it to you. Yep, so you put in 2 for your base, and 256 for your number. So if you go math, you go all the way down to A, log base, you can put whatever you want in there. So if you have the newer calculators, you have a little cheat code there. If you have an older one, you have to use change of base. Alright? Any questions? Sweet. Subscribe.